Hello all, so now we will continue with our Langgraph playlist, and this video will be focused on parallel workflows. So as you can see here, we'll build this workflow exactly, and the goal here is to understand two things. First is how to invoke chat models via Langgraph or LangChain framework, and I'm going to use OpenAI models because I have OpenAI API key, but you can use any other models, for example Claude. And you will see that we will make a simple workflow where this node will generate the joke. We will give one topic and there will be a joke, a story, and the poem of the same. And at the end, there is an aggregator node which will aggregate. But the goal is to understand the parallel workflow. Okay, so let's continue. So here in our first part of our Langgraph playlist, or first in the very first lecture, we have seen a very simple workflow of Langgraph, how to add a node, what is edge. Okay, so I'll be following the same pattern. But here the difference is we are using now some chat models. So simply, firstly, let me show you the requirements.txt. So apart from Langgraph, I have now LangChain. There is a LangChain OpenAI, and there is a Python.n. Why? Because we will need API key. Okay, so these three are the extra requirements. So what I did is just run this pip install -r requirement.txt in your environment, in your terminal, and it will install all this. Okay, so this is done. And now this load environment, as I said, will be used to load your API key. So in my .n file, you have to make one .n file where you have to put your API key. I can't show you the full API key. Okay, so I'm just showing the last part, but it always starts with SK. So if I print here for 7 characters, you will see I just print for 7 because this is very confidential. And if you guys will use it, then I'll get charged. Okay, but I'll show you how to get it. So if you will go to this platform.openai.com, then you have to build your profile, and these are the API keys. Okay, so this is how you get your API keys, and just you have to invoke here. Okay, this API key. So this is how this load env library can be helpful. So this will load all the environment variables from this .env file. Now, how to use that? So I'll show you the example that we can create. I'm just using ChatGPT Nano because you can see different billings, that how much it costs per tokens. I'm using very small model, but you can use a very powerful model as well. Okay. So now this LLM instance is created. Now if I write llm.invoke, what will happen is I'll just write hello, not hello world, but I'll just write hello. Okay. So what will happen is it will just reply us like, hello, I am your assistant, how can I help you today? So see, so if you are not sure how I like, how can I, here I can do few things, answer or question, explain, writing. So it's just giving you a basic thing, basic introduction about itself. Okay, this ChatGPT 5 nano model. So this is how we will use this LLM. Now again, first things first, as we made our class, or you can say state here, like we just wrote a very simple thing in first lecture, which is to add two numbers. So here as well, since our workflow is to generate a joke about a topic, so we'll again have the same class. We'll define the state, and there will be a topic which will be of type string, of course, joke, of course, string, poem, story, everything is string, and combined is also string. But now let's start with building our nodes. Okay, so firstly, let's build the workflow like we did for first lecture, and then we will start adding nodes. So this is just creating a workflow. Okay, so we are just passing the state which we defined here. So let me just start running the state as well. So this is my state, and now this state is being passed through state graph. So this is what we did already in the first class. So we are just using this state graph, and now let's add the nodes. So as we know that what we need 3 parallel nodes, right? So what we will do is what we name parallel builder. There can be a good name. Dot add node. So what I'll do, simply add node, and I don't want this. This is the suggestions that I'm getting. But what we will do is we know that what to do. So let's call it here, call LLM1. Okay, you can name anything here, but I'm just naming it call LLM1, and we will call the function call LLM1. call LLM 1. Similarly, we will be having call LLM 2, then call LLM 3. So let's see what we have. We have call LLM 1, 2, and 3. So we just need 3. Okay. So fourth one is not needed. So apart from this, what we need is aggregator. So fourth one should be aggregator. As you can see here, the last is aggregator, which combines the output. So we will be having an aggregator. So it's correct that it's suggesting the aggregator. Now time is to build all this. Okay. So which are nothing but our nodes. So let's build our nodes now. So I'll build one and then copy paste. So define call LLM1, or we can also say call LLM for joke, but let's follow the process. Okay, so state. So it takes input as a state, but output I don't want as a state. I explained you this, that while building parallel workflows, you can't just return the state. Okay, and why you will get it, I'll show you the error as well. What happens if you don't get it, do it. So here we don't modify the state because this is parallel. So if we modify parallelly, then all three call LLM1, all three parallel nodes will be modifying the same state, which is incorrect, which will give us error. I'll show you what error we'll get. Okay, so now what we have to do is, here instead of returning the whole state, because this state is being modified by all three. I'll show you this, but let's me just do it like this. Okay, let me first get an error. Let me show you that how we will get an error. Okay, if I'm just returning the state. Okay, so output will also be state. So this is where we will get an error, but let's see how we will solve it. Now it should be state. So first should be tell me a joke about any topic, tell me a story about this, and then third will be tell me a poem about this, and it should be llm.invoke. Yeah, dot invoke, and here as well dot invoke. Okay, and this helper that I'm using is windsurf, if you just want to know which one I'm using. Okay, sometimes it annoys, but it's useful in most of the cases. Then we called aggregator in our graph, so let me also call aggregator here. Again the state, and it will just aggregate and we will return the state. Okay, the state is built already. Let's just run this. So this is also done. Now no error lines, all nodes are created. Now let's connect. So it's time for edges now. So now you will see it's very intuitive to build parallel edges. So you will see, so it will start from start to LLM1, right? Because it starts from start to LLM1, start to LLM2, start to LLM3. So it will be the same. See, start to LLM1, start to LLM2, start to LLM3. Okay. Similarly, if you can guess, what we will have is, again, from this to aggregator, 2 to aggregator, 3 to aggregator. So again, it will be 1 to aggregator, 2 to aggregator, 3 to aggregator. Correct? Okay, now it's not suggesting. Yeah, suggesting now. And then aggregator goes into end. So aggregator goes into end. Very simple. So see how easy it is to build a Langgraph workflow. Now let's run this. And now let's compile to see if everything is correct. And if I don't store this in a variable, then we'll also get a picture. See, and this is what is intended, right? So I think we are going in the right direction. Now let's also store into a variable. We don't need this picture. We can plot this picture with iGraph. That not needed. Now what we will do is just try to invoke this workflow. So let's say our topic is cats, and I'm just invoking with the initial cats, and now we will get an error. We will see what error we'll get. So this is a good way to learn, by getting through the errors and then seeing that, okay, how parallel workflows gives an error when the same state is trying to be modified by all the three different nodes parallelly at the same time. If it's sequential, it's fine, because in our first lecture, it was sequential workflow, so it was fine. But in parallel workflow, you can't do this. Okay, and we'll see why in a minute. Okay, it's taking longer. Let's hang on. See, what it's saying is invalid update error. A key topic can receive one value per step. So why this happens is in parallel workflows. So let me explain this, that all of the three nodes in parallel are trying to modify the state. Okay. So what Langgraph understood is that, okay, to whom I should understand, to whom I should listen. If this is modifying the same state, this is modifying the same state, and this is also modifying the same state at the same time, then I don't know who is right, correct? And that's the reason that you can't modify the state here, but rather just return a dictionary with joke and the message. That's it. Do the same thing here for the story, and then do the same thing here for the poem. And now you will see that we will not get there. Let me rerun everything. Might take a while again, but hopeful that this time we'll get the output. But I'm not cutting or editing the video because I want to show you what happens when you modify the state in parallel, and what you should not do in that case. And that's why I showed you here in the first class. If you have paid attention, I have shown you that what we were returning, we were not returning the state, but what we were returning was a dictionary like this, and that was the reason. Okay, so if you will follow this process, it will work everywhere, even if in parallel workflows and even in sequential workflows. You can see we got some answer about cats, that why did the cat sit on the computer? It wanted to keep an eye on the mouse, something like that. So Moonless Ellie, this is a story, this is a poem. Whiskers in a quiet room, shadow, rain caught in the lamplight. So some rhymings are there. Okay, so all in all, you can say that it's doing the job. But the idea is to understand this workflow. So I hope you got this workflow, and looking forward to the next video. Thank you.